All right, y'all, today we have a problem, one problem that's our example problem, and we're going to be working on a topic called volume applications of polynomials. So obviously we will be working with volume today and polynomials. So let's go ahead and read through this example. Let's annotate it a little bit and get started. So example, a candy company packages its candy in rectangular prism boxes. Okay, so rectangular prism boxes with a square base that have both a length and width. All right, so let's go ahead and underline length and width 1 inch less than the height. Okay, so the first thing we're going to do for this problem is draw a picture that's going to represent like what we're even talking about. So a candy company packages its candy in rectangular prism boxes. This just means a box that's shaped like a rectangle. And a prism means 3D. So we're going to draw a 3D box. That's the first thing we're going to do. So I'm going to go ahead and draw a rectangle box. The way that I like to start is with a square, and then it's 3D, so we kind of extend from there. Doesn't have to be perfect. Okay, all right, so this is our candy company's packaging, and now let's go ahead and label the length and the width. So here it says length and width are 1 inch less than the height. Okay, we don't know what the height is. We don't know what the height is, but let's go ahead and read part A before we label our box, and it's going to tell us something about the height. Part A wants us to write a polynomial function, so polynomial function, call it v of x, that represents the volume, so v of x is going to represent the volume of the box with a height, a height of x inches. Okay, so we know our height of our box is x inches, so we can go ahead and put that on our box, label it on our box. This is the height, height equals x, right? Instead of having, actually, yeah, I'll leave h as x. Okay, so then let's break down the other sides. We need to label the length of the box, which is going to be this side, and then we also need to label the width of the box. Let's do the width of the box this color. And they gave us this information. Length and width are 1 inch less than. All right, so what operation is less than? Because length and width are 1 inch less than the height. So that's what we need to do. Well, our length, let's go ahead and write L equals, less than is subtraction. So minus 1 is what we're going to do. We're going to take away 1 because the length and the width are 1 inch less than the height. So length equals x minus 1, because remember height is x. So 1 inch less than the height, that's the same as h minus 1, but h is x. So that's the same as x minus 1. And then our width equals, it's the same thing, 1 inch less than the height. So we're going to call our width x minus 1 as well. Okay, so now we need to write a function for the volume of the box. So let's go ahead and write that function, volume. And before we write the volume function, let's just remember, what is volume of a 3D box? Volume is length times width times height, right? But we have different values for these. And I'm actually going to put the height first. I'm going to put h first. So let's go ahead. Since it's multiplication, we can reorder it. So height times width times length, right? Okay, and then we're going to plug in. We're going to plug in our h, our w, and our l, like the actual values for those. So let's write our polynomial. V of x equals, and now we're going to plug in for the height. We are going to plug in x is the height. So instead of h, we're going to put x. And then for the width, we're going to plug in x minus 1. So times x minus 1. And then for the length, we're going to plug in x minus 1 also. So times x minus 1. So we just wrote an equation for volume that is height is x, right, times width was x minus 1, times length was also x minus 1. Sweet. This is our equation, our volume equation. Now, the next thing we're going to do is we're going to convert this to standard form. So let's go ahead and convert this equation to standard form. How are we going to do that? We're going to multiply. So we're going to multiply, let's go ahead and multiply these two first. Here, let me go ahead and erase these colors. We're going to multiply the x minus 1s first, these two. So let's go ahead and multiply those two using the box. So we're going to put x minus 1, because we want to get this polynomial into standard form. And you'll see why in a second. All right, x squared, we have minus x, and then plus 1. So we get x squared minus 2x plus 1. That's the same as these two, x minus 1 and x minus 1. So let's go ahead and plug that into our volume equation. So v of x equals, don't forget your x out in front, bring this x down. So we have x times x squared minus 2x plus 1. Sweet. And now we can distribute this x in. So we get v of x equals, and this is the volume of the box, x cubed minus 2x squared plus x. Okay, here is our volume. Go ahead and label that volume. That's the volume of the candy package. Now let's move on to part B. See what part B is asking us to do. Part B asks us to find the dimensions of the box. So dimensions just means find what length and width and height are. Find the dimensions of the box if the volume, okay, this is really important, volume is 2 cubic inches. Units on volume is always cubic. All right, volume is 2. So what could we do with that number 2? Where could we plug that in? Well, what in this equation that we wrote, what in this equation right here represents volume? Which part of the equation? The v of x. This is the volume. So we are going to plug in, we're going to plug in 2 for that whole left side. The volume, we're going to make 2. So let's go ahead and do that. And so where we see v of x, we're just going to put a 2. So we're going to say 2 equals, and leave everything else the same. X cubed minus 2x squared plus x. All right. Then we need to solve for x so that we can find the length, the width, and the height. So how do we solve for x? Well, this is a polynomial. And anytime you have a polynomial, it's good to get one side equal to 0. So let's get that side equal to 0. Let's subtract 2 on both sides. Minus 2 minus 2. We get 0 equals x cubed minus 2x squared plus x minus 2. Sweet. Now, how do we solve a polynomial that has 4 terms? How do we solve polynomials with 4 terms? Factor. What type of factoring can we use when it has 4 pieces? Factor by grouping. So we're going to do factor by grouping to solve for x. So let's go ahead and group. We are going to do our first 2 terms in the first group, our last 2 terms in the last group, and pull out a GCF. So the GCF is x squared. Then we have x minus 2 left. We're going to bring down our plus sign, leave a space, and copy the x minus 2. There's that space. What do we need to have in that space? Well, just 1, right? Because 1 is the GCF in the second group. Okay, and now if we're going to continue, we need to bring down the x squared and the 1 into their own parentheses. So x squared plus 1, and then x minus 2. And now we need to decide, can we factor any more? And remember, like 0 equals is on this side, 0 equals. Can we factor any of these terms anymore? You may have said that we could factor the x plus 1 more. X squared plus 1, sorry. Well, you may have thought that we could use difference of squares on that. But is this a difference? Difference means subtraction. So you actually cannot use difference of squares on that. We cannot factor that anymore. So we need to solve now. We need to find the zeros, solve that. So how do we solve? We set the factors equal to 0. Set the factors equal to 0. So we're going to say, okay, x squared plus 1 equals 0. And then we're going to set, you could set this factor equal to 0. But most of y'all know how to find what x equals for that factor. What does x equal for this factor? Switch the sign. X equals 2. But we still need to find the solutions for this factor. So let's go ahead and solve. We go minus 1 on both sides. X squared equals negative 1. We're going to square root both sides. Square root, square root. When you square root a variable, make sure you do plus or minus on the other side. And then this cancels. The square root and the square cancel. So we get x equals plus or minus the square root of negative 1. Well, we're not allowed to square root negatives. So we need to take that negative, bring it outside. What does it turn into? The letter I. So x equals plus or minus I times the square root of 1. Well, what is the square root of 1? The square root of 1 is 1. So x equals plus or minus I. Okay, we have options for our solutions. We could say either x equals plus or minus I, or we could say x equals 2. Well, what the heck were we trying to figure out again? We were trying to figure out length times width, or we were trying to figure out what length is, what width is, what height is. So let's go ahead and bring those down from before. Remember, we wrote the length equation. Length was x minus 1. So L equals x minus 1. The width was also x minus 1. And the height was x. H equals x, right? Now, let's think about, we have x's here. We have x's here that we could plug in. We could plug in x equals 2, or we could plug in x equals I, plus or minus I. What the heck is I? I is an imaginary number. This is imaginary. Are we solving an imaginary problem? What's the problem that we're solving? We're talking about a real box. It's like a box for an actual candy company. That's real. This is real. We cannot have imaginary solutions to a real problem. So guess what we get to do? We get to say, forget this solution. It's imaginary. It doesn't make sense. Doesn't make sense for a real problem. Okay, so since we got to cancel out that one for a real problem, it does not make sense. So since we got to cancel out that option for x, we only have one more option for x. X has to equal 2. So this is our answer, x equals 2, but it's not the answer to the problem. This is just the solution, x equals 2. The problem was asking me, what is length, width, and height for this problem? So what we're going to do is we're going to plug in 2. Plug in your solution. So L equals, we're plugging in 2 for x, because x is 2 over here. It tells us that. We're going to do 2 minus 1. So what is L? 1. That's the length. Width equals x minus 1. But we're plugging in 2 for x, so we're going to say width is also 2 minus 1, which equals 1. And then height is x. What did x equal? We're plugging in what for x? We're plugging in 2. So height equals 2. Okay, and then the last thing we need is our units. So what are our units for this problem? If you read back in part B, it tells us that the volume is in cubic inches. So the units for length, width, and height are going to be inches. So let's just go ahead and add our units. Length is 1 inch, width is 1 inch, and height is 2 inches. These are our answers, and we are done solving this problem. Length, width, height. All right. Y'all are going to now do some practice. Good work.